So let's continue factoring trinomials. But now, would you notice that the coefficient in front of the x squared term is not a 1? This causes a problem. It makes it a little bit harder. So let's go ahead and talk about why first. So for example, this problem right here is going to factor into let's see, I've got to think about this a minute. 2x plus 3 times x plus 1. So let's just FOIL it to see why. So 2x times x is going to be 2x squared. 2x times 1, here is a 2x. 3 times x is a 3x. Those are going to happily add to be the 5x. And 3 times 1 is 3. So this is going to be the answer to this problem. It's going to be 2x plus 3 times x plus 1, but I would like you to notice that no longer do two numbers multiply to be 3, this last number, and add to be 5, the middle coefficient. We have a 3 and a 1 here. Yes, they do multiply to be 3, but they do not add to be 5, and they will not unless it's just a fluke of nature here, but that is never the case. So we have a couple of options. Option number 1 is to just guess and check. So this is not going to work. So option number 1 is to look at this problem and go, I've got to factor this into the product of two binomials, and because this is a prime number, 2, this has to be a 2x and a 1x. Or this could be a 1x and this be a 2x, period. And then the two numbers that go here are going to have to multiply. Their product is going to have to be 3. And so the two numbers that multiply to be 3 are just 1 and 3. So I'm going to do this wrong. So I could try putting a 3 here and a 1 here. Oh, actually, that is correct. I'm sorry. And what I do is I just check what I call the smiles. So this right here is a 3x, and that right here is a 2x. And if those inside and outside do add to be the 5x, I know I have found the correct factorization. Let's pretend I had done that wrong. I meant to do it wrong. So let's pretend that I had put the 1 here and the 3 here, and I went to check the smiles. So this smile, the inside smile, is a 1x, and the outside smile is a 6x, and they add to be a 7x, which is not that middle term. So this is what I mean by guessing and checking. Let's go over here and try this one, because this number 7 is a prime number. So it's kind of nice. So I know that I'll need a 7y and a y here, so that when I FOIL that, I get 7y squared. And I still do need two numbers whose product is 5. So my only options are 1 times 5 and a negative 1 times a negative 5. And, you know, I want the middle terms to add to be a negative 12 when I put those answers in. So it's either going to be a negative 1 here and a negative 5 here, or it's going to be a negative 5 here and a negative 1 here. So that again, I do get this positive 5 at the end. And I just have to check my smiles. So this smile is a negative 1y, and this smile is a negative 35y. They combine to be a negative 36y, and that is not this term. So in my second guess, that smile is a minus 5y, and this smile is a minus 7y, for a total of a minus 12y, and I can say, bingo, I found the factored form by guessing and checking to see that my smiles work, because I know 7y times y is 7y squared, and I know a minus 5 times a minus 1 is the plus 5. I just want to know if the inside and the outside gave me that minus 12y. Now I have to tell you, this is how I factor. I'm very good, you know, it happens to be what I do. I'm good at multiplication. I'm good at seeing numbers. But there is a method that you can use that does not require this guessing and checking. And I think I'm going to try it with this problem first. But, you know, one more time, just to check this, because the first coefficient is a 5, it's easy to put a 5z here and a 1z here. And then I need two numbers whose product is 3. So it's either going to be a negative 1 and a negative 3, or a positive 1 and a positive 3. Because the middles have to add up to be a negative, it's going to be a negative 1 and a negative 3. And my eyeballs can kind of see that that's a minus 1z, and this is a minus 15z, for a total of the minus 16z. So this is the answer to this problem. We've guessed and we've checked and we know it works. But let's come up with a tried and true method, and it works for all trinomials, even if this coefficient is a 1. So all trinomials can be done this way. But remember, when this coefficient was a 1, that was such an easy problem, because then you were just looking for two numbers whose product is this and adds to be this. All right, so here's the method. So we saw what our answer was, and let's go for the tried and true method that works every time. It's a little bit involved, but it involves factoring by grouping, which is something we did with 4 terms, so it's good practice. So we first multiply these two numbers together, the 5 times 3. If this were a 1, it'd be a 1 times 3, so it works for all trinomials. So those two numbers, their product is 15. So careful, that's the hardest part to remember. 5 times 3. And then I do want two numbers whose sum is the middle term, which is a negative 16. This one right here. And I can kind of tell it's going to have to be a 1 and a 15. But I want them to add to be a negative 16, so it's probably going to be a negative 1 and a negative 15 that will add to be this negative 16. Surely not a 5 and a 3 won't add to be 16. Now, this is the key. The 16z, that one term, will now be replaced with two terms called this right here. They will be called a minus 1z and a minus 15z. Tell me, don't those collect to be a minus 16z? So you use these two numbers to replace this one term with 2. Then you bring down the 3, you bring down the 5z squared, and now you have 4 terms. So you get to practice factoring by grouping, which is to group the first two. Don't forget, this is a minus sign in front of the third, so you're getting that negative 15z in there. And then the greatest common factor between these two is just the letter z. You factor that out, and you'll have a 5z here, because that gives you 5z squared, and a minus 1 here, because z times a minus 1 is the minus 1z. The greatest common factor here is a 3, but because this is negative, I'm going to factor out a negative 3, so that I can have a positive 5z here, so that when I multiply those, I get the negative 15z, plus I'm peeking over here, and I want this to be a 5z minus a 1. And is this minus 3 times this minus 1 the plus 3? Sure enough. So the common binomial factor is 5z minus 1. I bring the z and the minus 3 down into the other grouping symbol, and I guaranteed, no guessing, no checking, to have this problem work. I'm going to go back to one of the easier problems before we move on. So let's, this one's not so bad, so let's go here. So before we get to a harder problem, and then I'm going to break this segment into a couple of videos because it's pretty involved. So in this problem, I'm looking for two numbers whose product is 35. Product is a positive 35. And I want those two numbers to add to be a negative 12. So if their product is a positive 35, then I'm going to use the same signs. But I want their sum to be a negative, so I have to use two negative numbers. And the only options for product is 35 are 1 and 35 and 5 and 7. And the negative 5 and the negative 7 add to be a negative 12. So see this negative 12y? I'm going to replace that with either a minus 5y and a minus 7y, or a minus 7y and a minus 5y. It will work no matter what order you choose, always, I promise. I'm going to use this order because then, again, it will always work. I'm going to bring the 5 down to go with the 5y. It just kind of seems to make more sense, but it always works. And I'm going to bring the 7y squared to go down with the 7y. And I'm going to group the first two and group the last two. And a 7y factors out of these two. So I have 7y times y minus 1 when I factor out the 7y. A 5 will factor out of both of these, but because this is minus, I'm going to factor out a minus 5 so that this can be a y minus 1. I want it to match this, and I need this negative 5 times the negative 1 to be the positive 5. They match, and then I'm guaranteed to bring the common binomial factor down and then the 7y minus 5 in the other binomial. So what if, before we close this segment, what if it's hard for you to come up with the two numbers whose product is 6 times a negative 14? Product is 6 times a negative 14. Let's see, that's 24, carry the 2, 84, and it's a negative 84. And then I want those two numbers to add to be a negative 17. I have a trick for you. If you take your graphing calculator and you put into the y equals key, see this negative 180 divided by x? I'm going to clear that. See our 84? If you tell the calculator to take a negative 84 and divide it by a number, x, and you ask the calculator to start at 0 and go in increments of delta of 1, and then you look at a table of numbers, you see that 1 times a negative 84 is 84, 2 times a negative 42 is 84, 3 times a negative 28 is 84, and it just keeps going up for you. You can arrow down. Look at this 4 times a negative 21 and see the 17? So I've created a list of factors that multiply to be a negative 84. Now mind you, I may need to put the negative sign over here. So I just have to have the ability to know that if it was 4 times a negative 21, it could also be a negative 4 times a positive 21. So it does happen though, I want this to be 4 and a negative 21 because I want them to add to be the negative 17. Now I got to tell you, when I got a positive number and a negative number, I personally tend to put the negative 21w first and then the positive 4w second. Those do add to be the negative 17, right? Because I like to have a plus sign between my second and third terms if I have control over that. And I do because the signs are different. So I'm going to bring down this minus 14. I'm going to bring down the 6w squared. I'm going to group the first two and group the last two. There is no guessing here. The greatest common factor here is a 3 and a w for both of those. I think that's the biggest thing I can get out of that. So I'll need a 2w here, so that product is 6w squared. I'll need a minus 7 here, so that product is a minus 21w. And then the greatest common factor between a 4 and a 14 is a positive 2. And I'll need a 2w here, because 2 times 2w is 4w. I'll need that minus 7. Good thing, because I want those to match. I'll bring down that common binomial, and then I'll put the 3w and the 2 in its second binomial. Don't forget I can FOIL this to check it, and this works every time. We're going to practice this some more in the next video. It's a tried and true. Any trinomial can be factored this way.